Greetings and welcome to our video presentation. My name is Steven and I'll be narrating this video. Our team's project is the Robotic Arm Follower, a 3D printed robotic arm that is capable of following a person's arm movements. While a real arm has 7 degrees of freedom, our robotic arm has 4. This includes the shoulder pitch, the shoulder yaw, and the elbow pitch as shown in the picture. The robot also has a gripper that acts as the 4th degree of freedom. Here's a sketch of our conceptual design. The wearable device is attached to a person's arm. It includes a gyroscope, an encoder, and a button. The gyroscope senses the shoulder pitch and yaw signal. The encoder reads the elbow pitch signal, and the button is used to control the gripper. These input signals are processed by the microcontroller, and an output signal is generated. In terms of outputs, the robot arm has 4 servo motors installed, which controls the various joints. More details can be seen in the video demo later on. Now let's move on to the design choices. We used the MPU6050 gyroscope due to it being low cost and low power. This 3-axis gyroscope is quite accurate and has a built-in ADC that makes programming easier. It also uses the I2C protocol, which is perfect for communicating with the Arduino. We also use a rotary encoder as it generates digital signal, which is easy to process. In terms of the controller, we use the Mega2560 since it is relatively easy to program as the Arduino IDE has a great standard library set and many built-in functions. It also has a lot of I/O pins, which were very handy when we were testing out different input setups, since we didn't have to switch out and reprogram pins constantly. Lastly, we decided to use the high-level language as it is easier for debugging and modifying the codes. Now let's move on to the video showcase. In this first video, we have attached the sensors onto our teammate's left arm. The robot arm is held in a position that mimics the arm's position. As you can see, when the person's arm starts to move around, the sensor picks up the new positional information and the robot arm follows along. By pressing the gripper button, the gripper would open and close accordingly. Moving on to the second video, this one showcases a simple pick-and-place operation. The robotic arm will pick up an object and place it at the location marked with an X. Now let's talk about limitations and future work. In terms of hardware, the rotary encoder has quite a low resolution of only 9 degrees, which makes it unsuitable for capturing precise movements, though it can always be upgraded. The servo motor has a low torque value and can only move between 0 to 180 degrees, which limits the robot's positional capabilities. In terms of software, the choice of programming on the Arduino Mega board has the downside of being inefficient compared to using a microcontroller directly. The program also does not have PID control implemented, making it prone to issues such as oscillation and steady-state error when the person's arm is moving around fast. As mentioned before, these limitations can all be overcome by modification and improvements in the future. And that concludes our presentation. Thank you for listening.